Hello guys. So today here we are going to solve, you know, the problem posed in our daily Leetcode challenge for the day. And this is a very interesting problem. It may look little difficult, but once you get the hang of it, it becomes very easy. So, basically this problem is asking like, what is the minimum number of arrows which we need to burst all the balloons? And this obviously this is going to return the count of minimum number of arrows. And so let's go into the details of this problem. And for doing the count, you have to make a choice, whether you have to include increment the count for this particular balloon or not. So these things, if you take into consideration, this will lead you to a greedy algorithm. uh, because in greedy algorithms you create your solution piece by piece, okay, and you make the feasible and locally optimal and irrevocable choices at each step. So let's go, let's just see what is the detail of this problem. So in this problem it is said that there are some spherical balloons tapped onto a flat wall, any flat wall. So that represents the XY plane. Flat wall, it's one dimensional. I meant to say two dimensional. So it's XY plane. The balloons are represented as 2D integer array points. Okay. Where point 1 I is equal to X start and X end. Denotes a balloon whose horizontal diameter stretches between X start and X end. So this is what it is saying, So, let's see in this example. So the first point is 10 to 16. So first balloon is starting from point 10 and it is going till point 16. So it is, 6 unit big. Second is, starting at 2 and it's going till 8. So it is also 6 unit bigs. One, third is starting at 1 and going till 6. So this is, 5 units, in size. And then the fourth one is also, 7 plus 5 is 12. So it's also 5 units big. It's starting at 7 axis, x-axis, and then going till 12 x-axis value. So it's asking like, what is the minimum number of arrows which you can shoot? Obviously, if you see, see 2, 8 and 1, 6 are overlapping. So they can be shot down with one arrow, correct? And then 7, 12 and 10, 16, in between this, if you shoot down your arrow from x-axis 10 or from 10 to 12, any point, you'll be able to shoot down both the, balloons. So you need, by looking at this example, you can make out, you need just 2 arrows to shot this down. And this is what, this is what it is, explaining here, that you can shoot down with these 2 arrows. So the thing is that how do we, get to this conclusion programmatically? And as I mentioned that, you are going to do this, you are going to develop an algorithm, and the algorithm will check like whether for this particular, balloon, you need to shoot a new arrow, or from the existing arrow, you can make it out. So this is, very similar to interval scheduling problem. And as we know that in interval scheduling problem, we first sort, for that matter, any greedy algorithm, we first sort the input, input given to us. And input is usually an array, or, as in this case, it could be, array of arrays. So basically, the approach that we take in any greedy algorithm is that we sort this array. So let's just start with sorting it up. And as I mentioned, interval scheduling algorithms. So many of you would be aware that in interval scheduling algorithms, we sort the array, the input array of intervals on the finish time. So why on the finish time? Because that is what is the correct way to go about it. So we'll take the finish time. Finish time of A is A1 and finish time of B is B1, because B0 is the start time and B1 is the finish time. Same is for A. A0 is the start time and A1 is the finish time. So we'll, this will give us, this will sort the input points array on the basis of finish time. And we will take the first one, and, we will first, obviously we are going to return the count. So we will take one, route. So what we have done here in this, we have taken, the breadth of the first array, which is going to be, least finish time. So this breadth we have taken, and then we are going to, compare the next value in the, points array. If its start time is, more than this finish time, then we have to, go for another array, a new array. If it is within this, 0, 1 range, then with the existing array, we can, do the work. So existing array, so for existing array, we'll have the count 1. Okay. And now, we'll have to go through the, so point will, denote one array, and points is going to denote the input which is given to us. And in this, what we'll do, that we will check if rightmost till now is greater than, is less than, is less than point of 0. If, if the rightmost point, like suppose in this case, the smallest finish time is 1 to 6. So after sorting, 1 to 6 will be the first element, and this will be taken into account. So 6 and then this 2, 8. So we'll compare 6 with 2, but 2 is smaller, not 6. But if 6 is smaller, let's say, the start time of this is, 2, 8 is not there, we have 7, 12. Then one arrow for this balloon and one arrow for this balloon. But since 2, 8 is also there, so one arrow for this 1, 6, and the same arrow will tackle this 2, 8 one also. So that's why we are, doing this strict check. Okay. So if this is the case, then we are going to increment the count. Yeah, I'm going to say if the rightmost till now is smaller than the next, start value of the next balloon, then we'll increment the count because we need another array for this new point, and we'll update our rightmost till now with the, in current value of, point. This, second value of this point array, and at the end we are just going to return this. Done, we are done. So this is the way to solve this problem. Let's see, how it performs on the sample cases. Perfect. So it's working fine. It's giving as expected. So now let's submit it. Perfect. Perfect. So see, for a medium problem, we have taken only few steps to come to a solution. And this is the best part of this, if a problem is rated as a medium, it need not be, very tough. So we should be very, we should be thinking that, any problem which is even rated as medium can be solved with only few lines of code. With this, I would like to say thanks to you. If you have any doubt, any problem, please let me know. I'll, post it in the comments, and I'll certainly respond. Thanks a lot.